بسم الله الرحمن الرحيم. Inshallah, today we'll start talking about this section 5.5, integration by substitution, which is a very simple idea. The idea is very simple. It's kind of the, I mean, let me say the reverse of this composite or the chain rule. You know that the derivative of f of g of x, let me say capital F of g of x will be what? Capital, it will be capital F prime and g of x times g prime of x, chain rule. Yeah. So the antiderivative of this will be this one, which is this. That's mainly the idea. And yeah, the book is taking it in two ways, where the you can see it as a pattern. You can do it quickly. Just see this and the function and its derivative, or the and then you can do it quickly, or the usual way, which is by let. You let u equal g of x, du equal, if u equal g of x, then du will be d prime of x dx. Then you arrange the integral so that you will get an integral that easy to find. Yeah, I will try to do these these simple functions easily in two ways. If you notice here, what we have, this is e prime of x, and this is f of g of x. You know what? Maybe this one will be easier, which is very clear. Okay. Let me do this. Let me go with this one. G prime of x. This is f. Yeah. This is g. So I have capital F of g of x, or small f. I mean small f of g of x, where my g, you know, this is x squared plus 1. So this is its derivative, and this is f of x squared plus 1. So this is like f square. F is like the outer function is the square. So it will be, the answer will be u, I mean, the antiderivative of square of u square, which is u cube over 3, where u is x squared plus 1. Yeah, this is the idea for the pattern, but I think the best way is always to, you make it with let. You will say let u equal x squared plus 1, then du will be what? 2x dx. So this is your du, and this is your u. So the integral will be what? U square du, which is easy to do now. So the main idea is that we'll use a substitution. You can do any substitution, but the one we are looking for is a substitution which will make my original problem easy to integrate. This one I know how to integrate it. So this is the mainly the idea. Doing substitution, you can do all the substitution you like, but the most important thing, the new integral should be easy to do. This I know how to do it. U cubed over 3 plus c, antiderivative things. And u is what? X squared plus 1, because I need the answer in terms of x. Yeah, so I think this will be easier than, yeah, let me write it here. This pattern, yeah, the pattern also you can do, but you need to You need to practice it a lot. But I think the let u is make it easier, and you will see it clearly for most of these, for all of these problems. Here, if you notice, yeah, yeah, if I let u equal 5x, so this is f of g of x, which is f of 5x, which is my f is e, and this is 5 is g prime of x. This is the way to look at it, as a pattern recognition. So my original function is e. They know is the integral of e is e. So that will be e to the power 5x. That will be my antiderivative plus c. And this is g. By letting u, it will be easier. U equal 5x, then du will be 5 dx. That means what? These things is du. So the integral will be e to the power 5x, which is e to the power u du, which is e to the power u. This is I know how to integrate it. And 5 dx is du. So I have e to the power u du, which is e to the power u plus c. What is u is 5x plus. Okay. This one, the same idea, but a little bit. You need to be careful with one thing. Now, if I let u equal x squared plus 1, what will be du? 2x. I don't have 2. I need the 2x. I have x only. So I can put 2 and put half outside. Multiplying by 1, which is nothing. But that will help. This one is my du now. So the answer will be half integral. This is my u squared du. By the way, this problem is the same as this one, almost. But I have 2 here, I don't have 2 here. Okay. So it will be half u cubed over 3 plus c. So it will be x squared plus 1 cubed over 6. Half times c, I can write it plus c. So that will be the answer. Okay, as I said, the main idea is you look at the problem, you need a specific substitution, which will make the new integral easy to find. That's mainly the idea. Substitution is just to change the function instead of x, you change it to another function in terms of u. If it changes in terms of u, it means you need to change everything in terms of u. You cannot leave x with u, so it should be totally u in terms of the new variable u, v, the way you like it. Okay. Here, what I will do, I'll take this. Let me write it. I'm leaving a space here for a purpose. U equal to x minus 1. What will be du? 2 dx. So I need 2. So I have 2, where this is my du. Multiply by 2, I need to multiply by half outside. So that will be what? The integral will be half u to the power half du, which I know how to do. And that gives me what? That gives me half. This is the add 1, 3 over 2. So you have times 2 over 3, u to the power 3 over 2 plus c. So I have 1 over 3. U is what? I put 2u, 2x minus 1 times 2x minus 1 to the power 3 over 2 plus c, which is the answer should be 1 over 3 square root of 2x minus 1 cubed plus c. We'll do the same idea here. I need 2 and I need half. Not only that, if you let u equal to x minus 1, then du is 2 dx. Okay, now write the integral. That will be half integral 2 with dx. That will give me du. Okay, square root 2x minus 1. That will be u to the power half. What about the x? What shall I do with the x? Okay, what I will do from this substitution, I can get x. I have u plus 1 equal to x. So x will be u plus 1 over 2. As I said, I need to change everything in terms of u. So that will be u plus 1 over 2. Okay, now I do the calculation. That gives me what? 1 over 4. Take it outside. I have u to the power 3 over 2 plus u to the power half du. Until now, I did not do the integral. I did not do the integration. Now that will be what? 1 over 4. This is we add 1, 2 over 5, u to the power 5 over 2, plus 2 over 3, u to the power 3 over 2, plus c. In other words, that can be written as what? Yeah, 1 over 5. I know u. U is what? 2x minus 1 plus 2 over 3, 2x minus 1. Don't forget plus c. Okay. Also, we can deal with it also with the trig functions, with any functions. The same idea, you can do it with any functions. So here, what will be my u? I will let u to be cosine 3x. Yeah, someone maybe said, why not sine? You cannot do it with sine. You can, but it will make it a little bit complicated. But oh, can I do it with? Can I let u cosine? Yes, you can do that, but it will be more complicated the other way. I let u this one. So I have u square, and this will be my du times a constant. So this is the way to look at it. The things which has the squares or square root or these things, this is the things which you expect to make it as u, and the rest will be kind of du. So I will let u here sine 3x. Cosine will not work. It will work. No, sorry. It will work, but you need a little bit of calculation. So you need to write sine square. No, it will not work. If you let u equal cosine 3x, then what you will do with this one? You need the integral. Let me just show you what will happen. Let u equal cosine 3x. Du will be what? Minus 3 sine 3x. If I took from this one, I make it sine 3x, sine 3x. Yeah, this will go with du. What about this one? How you change it into u? So you have sine 3x times u du. So you are mixing u with x. So that will make it complicated. However, if you do it the other way, if you do it u equals sine 3x, what will happen? Du will be 3 sine 3x dx. So I need 3, and I need 1 over 3. This 3, the cosine 3x dx, that will be my du. So the answer will be 1 over 3 integral of u squared. This is my u, sine 3x. U squared du. Done. Easy now to do the calculation. That will be what? 1 over 3 times u cubed over 3 plus c. What is u cubed? Is sine 3x. So it will be sine 3x cubed over 9 plus c. Yeah, so the main idea is not only doing any substitution, you want to do a substitution where the new integral is easy to find, easy to do. Okay, so this is mainly, but the idea of the substitution actually you can do it with any u. You can put u the way you like, but the most important, will this new integral, if I change this to this, will this new integral be easy to integrate or not? So we'll choose a substitution. Usually it's best to choose the inner part of the composite function, like sine 2x all square. I choose the inner part, which is sine 3x. Here I have 2x minus 1 to the power half, and the inner part is 2x minus 1. Usually this is the way you look at it. Raised to power, quantity raised to power. Compute du, which is usually g prime dx, which is easy to do. Rewrite the integral in terms of this variable u. Find the resulting integral. This is the most important thing. Then you go back, replace u by gx, check by answer. You can check all of your answer by substitute, by differentiating. Okay, let me do more problems. Yeah. Well, before I do the problems, this is substitution, but would emphasize in the power rule. Okay, I know this is the derivative of this will be this one. So just he reversing it. Yeah, some people they like to think about it this way. But I think in general, you do the substitution, then you will see it. Then you apply the antiderivative for u to the power n, which is u to the power n plus 1. So like in this one, I have let u, the inner part of this composite function, with 3x minus 1. What will be du? Will be 3dx. So this is my du. This is my du. So what I am getting, I'm getting u to the power 4 du, which is I'm using this now. Just he want to emphasize, sometimes when you do a substitution, you will get the integral of u to the power of value, which is easy to do as the reverse of the power rule for the differentiation. That will be u to the power 5 over 5 plus c. And what is u? It's 3x minus 1 to the power 5 over 5 plus c. Okay, same thing here. That will be my u, because its derivative is this one. So if I took it the other way, if I took this u, this is not its derivative, so I will be stuck. So I will let u equal ex plus x. What will be du? It will be ex plus 1 dx. So this will be my du. So the integral will be u du. That's it. So using the rule, I have u square over 2 plus c. So it will be ax plus x square over 2 plus c. Okay. Here in this one, this is the inner part of composite function. So I let u equal x cubed minus 2. So it will be du. It will be 3x squared. So that will be my du. Don't forget the x. So this integral will be u to the power half du. In these three cases, I'm using this power rule for integration, or general power rule for integration. Here I have u to the power 4. Here I have u to the power 1. Here I have u to the power fraction, half. Do the integration. That give me what? 2 over 3. U to the power 3 over 2 plus c. I retain the u, which is x cubed minus 2 to the power 3 over 2 plus c. You want to write it as the square root, or the way you like, it's up to you. Okay. This one, same idea, but now this is now the power should be negative. I'm doing it in detail since these are the starting examples. So you want to be sure everything is clearly Very well clear. And then we'll do more complicated problems. I let you this one. 1 minus 2x squared. What will be du? It will be minus 4x dx. Oh, so this is my du. So now I change everything. This will be du over u square, which is, I can write it u minus 2 du. Now, integration, I add 1. That will be minus u is minus 1 plus c. In other words, that will be minus 1. What is u? U is 1 minus 2x squared plus c. Same thing here. We'll go with the dx. So I'll let u, the inner part, so I'll let u cosine x in this case. What will be du? Is minus sine x dx. Okay. So what I will do, I will multiply by a minus, and multiply by a minus here. This with sine x dx, that will be my du. So the answer is minus integral u squared du. So that gives me minus u cubed over 3 plus c, which is minus cosine cube x over 3 plus c. Okay. More problems? I will let you this inner part of this composite function. What will be du? 4x cubed dx. I don't have 4, so I will have 4 and 1 over 4 outside. You know, the constant will not make a big difference. So this dx, that will be my du. So that will be 1 over 4 integral of cosine u du, which is 1 over 4 sine u plus c. So it will be 1 over 4. What is u? X to the power 4 plus 2 plus c. Okay, that will be the inner. Let u equal to x plus 1. Du, I need 2. So I'll put 2 and half outside. That will be half u to the power half du. That will be half times 2 over 3 u to the power 3 over 2 plus c. That give me 1 over 3 2x plus 1 to the power 3 over 2 plus c, which is 1 over 3. You can write it square root. It's up to you. 2x plus 1 cube. It depends on the way you see the answer. Okay, more problems. I said these are easy ones, but it's good to practice. To start with, I will let u is 1 minus 4x squared. Du will be what? Minus 8x squared. It means I need minus 8 here and minus 1 over 8 here. So that'll give you minus 1 over 8. I have du over u to the power half, which is in other words, u to the power minus half du. So now I can use the power rule for integration. That will be plus 1, it will be 2, so times 2, u to the power half plus c. So I have minus 1 over 4 times 1 minus 4x squared to the power half plus c. Okay, this one, I'll let u equal e to the power 5x. So I put 5, I put 1 over 5 outside. Where du, don't forget the x. Yeah, just put the x in all of these. Yeah. You put the du, you need the dx. Okay. That means du would be what? 5e5x. No, that will not help. It will help. It will help. Yeah, let me do it in 2 ways. The same problem. Let me do it in 2 ways. If u equal 5x, what will be du? It will be 5 dx. So this is 5, this is 1 over 5. So I have 1 over 5. This is the first step, first way. Yeah, sometimes you can do it in two ways. 1 over 5, where 5 dx is du, and you have integral of eu du, which is 1 over 5 e 5x plus c. This is one way. The second way, I let u equal e5x. Okay. What will be du? Du will be 5 e5x dx. What is this one? So the integral of, I put 1 over 5 and 5, make it easier. So 1 over 5 integral of 5 e5x dx. This is du. All of this is du. And this is 1 over 5 integral of u du. What's the integral of u? What's the integral? It will be du. Not all of this is du. All of this is du. So that will be 1 over 5 times u plus c. What is my u? My u is e5 to the 5x, e to the power 5x plus c, which is the same answer. So as I say, the most important thing about these substitution things, we need to find the substitution, which will make the new integral easy to do. Sometimes it's not only one way, huh? And sometimes, yeah. So you need to be careful about the calculation. Yeah, this is a little bit tricky. What we'll do here? Where am I? Yeah. Okay. This one, if I let u equal 1 plus x square, what will be du? Du will be 2x dx. I have here x to the power 5. I don't have x only. Oh, so the trick, the idea to make it clear, I can write x to the power 5 as x to the power 4 times x dx. Not only that, I can make this 2x. So multiply by half outside the integral. So this is my du, and this is u. So I have half integral square root of u. This is du. What about x to the power 4? Okay. From this one, I have u minus 1 is x squared. That means x to the power 4 will be u minus 1 squared. So now I change everything in terms of u. That will give me, what is it? Yeah, that will give me u minus 1 squared. So now I change all the integrals into u. That's it. And this one is easy to do. That will be half square root of u. This is square, u square minus 2u plus 1 du. So that give me half integral u to the power 5 over 2 minus 2 to u to the power 5 over 3. U to the power 3 over 2, I mean, plus u to the power half. What I did, I just opened the squared, u minus 1 all square, open this parenthesis, and then do multiplication. Now it's powers, easy to do. So I have what? Half, add 1, that will be times 2 over 7, u to the power 7 over 2, half times minus 6 times 10 minus 2, that will be minus 2 over 5, u 5 over 2, plus half times 2 over 3, u to the power 3 over 2, plus c. So that give me what? 1 over 7. U, which is, we say u is what? This is u. I return everything into x. X squared to the power 7 over 2 minus 2 over 5. 1 plus x squared to the power 5 over 2. Not, yeah, 2 over 5. This one plus 1 over 3. 1 plus x squared to the power 3 over 2 plus c. Yeah, I think this is the answer. This is explained in 5.8, but actually, yeah, the same idea. I think in 5.7, I mean, it was explained in 5.7, so this should go to 5.7. But I told you the idea very clear. What's the idea is that this one is sine x over cosine x dx. So what will happen? I will let u equal cosine x. What will be du? Du will be minus sine x dx. Yeah, so I'll put minus here and minus outside. So I'm getting what? Minus integral du over u, which is I know how to do. Actually, he tried to emphasize in this one using that the len in 5.7, but I think it can be done also. So I have minus len absolute value of u plus c. So the answer is minus len cosine x dx, or what's the x? Plus c, I mean. And this minus 1 go as a power. So that will be len secant x plus c. Yeah. And actually, you can check. What's the derivative of this? It will be secant. Here you have secant tan, which give me tan. So you can easily check it. So this is the answer. Sometimes you see it this way, sometimes you see it that way. As I said, that will be explained in 5.7. Okay. Now, now we need to deal with the all the examples before about indefinite integral. Now we need to deal with the definite integral. It's the same idea, exactly the same idea. But when you do the substitution, these limits of integration should be affected. So if I have a, that will be g at a. With the substitution, u equal g of x. If I have b, that will be g at b. Actually, you can solve it in two ways. You can change these limits. So خلاص, this new integral, you can find it easily with the new limits of integration. This is one way. The second way, you can deal with it as indefinite integral, and you do the definite integral at the end. You can do both. Both will be correct the way you like it. The usual way, they do the substitution during they do the changes of this limit of integration during the substitution. So I'll let u equal x squared plus 1. What will be the u? The u will be 2x dx. So I need 2.5. Okay, so the integral, let me call it I. So I will be what? Actually, I need to do, maybe I need to do this I in all the previous ones. That will be half integral. That is my du. So I have u cubed du. Be careful about now the limits. Now I will change this limit instead for x to u. So if x equals 0, 0 plus 1, that will be 1. If x equal 1, 1 plus 1, that will be 2. So that will be my new limits. Okay. So that give me what? I will do now the integration. Then I will do this like what I'm doing in before. So I have half. This is u to the power 4 over 4 from 1 to 2. So that will be half times what? 2 to the power 4 is what? 16 over 4. That will be 4. 2 to the power 4 is what? 16. That will be 4. And 1 over 4. That give me half times what? Times 16 minus 1, 15 over 4. So that will be 15 over 8. So that will be the answer. Okay, this one, the same idea, but a little bit calculation. You let u equal to x minus 1. What will be du? Is 2 dx. But I have x here. So I can multiply by 2, multiply by half outside. That will be half integral. Oh, what about x? If u equal to x minus 1, x will be what? I have u plus 1 equal to x. So x is u plus 1 over 2. So that will be u plus 1 over 2. 2 dx is dx over square root of u. That will be the integral. Let me just make it. I change everything in terms of u. Okay. So what I have, this 2, I can't take it outside. I have 1 over 4 u over square root of u plus 1 over square root of u du. Yeah, I'm doing it in more steps. That will be 1 over 4 times what? U to the power half integral. Now the integral is still there. 1 over 4 integral u to the power half plus u is minus half du. So that give me what? 1 over 4. I add 1, that will be 2 over 3. U to the power. Oh, I forget one thing. Yeah, I did not take the limits of integration. You know what? I mean, sometimes you can do the integral and then substitute at the end. Let me do it this way. Deal with it like if it is definite integral. Usually the way we do it, we change the limits of integration during the process. But let me do it this way, this time. Deal with it as a definite integral. So I'm working as indefinite integral. I mean, I'm working in this problem as definite integral, as indefinite integral, I mean. This will be the process, this, and then at the end I'll make substitution. So will be u. I will make the limits of integration. U to the power 3 over 2 plus 2 u to the power half. Okay, and plus c. I don't need plus c at the end. That will be what? 1 over 6. Yeah, that will be what? 1 over 6 u to the power 3 over 2, which is x squared plus, no, what is x squared? What is u? U is this one, 2x minus 1, I mean. 2x minus 1 to the power 3 over 2 plus 1 over 2, 2x minus 1 to the power half plus c. This is the indefinite. Now I change everything in terms of x. So now I can use these limits, 1 to 5. So in 1 to 5, this integral, give me what? Just now I substitute. Give me this. Let me write it. 1 over 6. No need for plus c. From 1 to 5. Do the calculation. What you have? 1 over 6 times what? Yeah, calculation a little bit complicated. 10 minus 1, 9 cube root of 9 is 3 cube. That will be 27. Oh, 27 times 6. That will be 27 here. Plus half. This is 3. Okay. 9. Yeah, cube root of square root of 9. Let's give square root of 9. Okay, 27 over 6. And then we have what? Yeah. This is half times 3 minus, when you put the 1, that will be 1. That will be easier. 1 over 6. This is minus half. So my answer is what? I have 27 minus 1, 26 over 6, which is 13 over 3. Yeah, 26, 13 over 3. 3 over 2 minus half, that will be minus 3 over 2 minus half, that will be plus 2, plus 1. Yeah, 3 over 2 minus half plus 1. That gives me 16 over 3. As I said, you can't do it by doing the integration during the procedure, or you can leave it at the end where you deal with it as a definite and then substitute and do the limits of integration. Both are correct. Okay. I'll try to do those 4 problems, then I will stop. The remaining is just the even and odd. Maybe I will say it and then we'll do example next time. Okay, now let me do this quickly. I let u equal to x plus 1. What will be du? Du will be 2 dx. So I need 2 and half outside. So that will be half. This is 2 dx is du. So I have square root of u du. Integration, that will be 1 to 9. So I have half times what? 2 over 3 u to the power 3 over 2. خلاص, from 1 to 9. No need to change anything. 1 over 3. That will be what? Square root of 9, which is 3 cubed. 27 minus 1. So the answer is 26 over 3. Okay, this one, what will be your u? I let u equal 3 minus 5x. What will be du? It will be minus 5 dx. So that will be minus 5. And I need minus 1 over 5 outside. That's going to be minus 1 over 5 times what? Du integral, du over u square. That is what? Which is u to the power minus 1. That will be minus 1 over 5 times u to the power minus 1. Be careful. If x equal 1, that will be minus 2. If x equal 2, that will be minus 7. You notice now the limits of integration, this is bigger than this. It's okay. Don't do any changes. Leave it as is. Do the calculation regularly. So that from minus 2 to minus 7. So that will be minus 1 over 5. This is when you do the substitution, you're getting minus 1 over 7. Minus, that will give me plus half. So the answer is minus 1 over 5. Minus 2 plus 7. Which is, yeah. Wait a minute. Minus 1 over 5. That will be minus 1 over 7. Minus half, yeah. Okay, so it's plus half. So I have minus 1 over 7. Okay. Yeah, half minus 1 over 7 is what? Will be minus 2 plus 7. That will be 5 over 14. So the answer is minus 1 over 14. I can also check the answers. Minus 1 over 5. U to the power. Sorry, I forget the minus sign here. Oh, no, sorry. This is not u to the power minus 1. This is minus u is minus 1. When you do the integral, huh? There is a minus sign here. So this should be plus, minus, that will be plus, that will be plus. Sorry for that. The integral of u is minus 2 du is minus u is minus 1 plus c. So I need the minus sign here. Be careful. These things. Okay. This calculation. Okay. Now, also this one can be in 5.7. As you notice, 5.7, 5.8, you cannot distinguish between these ones and the one in 5.5. It's substitution. You let u equal ln x. What will be du? Du is dx over x. So now we do the integration. I'll try to do it again in 5.7. Ln 1 will be 0. Ln e will be 1. That will be the limits of integration. Now I have this as du. So you have what? U du. Oh, actually, it's not 5.7. This is okay to be here. Okay. U du. So that will be what? U equal ln x. Du is dux over x. So that will be u du. That give me u square over 2 from 0 to 1. So the answer is half. Okay. Just change the limit of integration. Ln 1 is 0. Ln e is 1. Okay. Yeah, this is from all the exams questions. Yeah, very clear. If this is u, then this is my du. So I let u sine inverse of x. Du will be what? 1 over square root 1 minus x squared. Don't forget the dx. So this integral will be, now I change the limits. Sine inverse of 0, this is 0. Sine inverse of half is pi over 6. And I have what? EU du, which is easily EU from 0 to pi over 6. So that will be E pi over 6 minus E0, which is 1. So this is the answer. Very easy one. The last things in this section, which I will stop at that one. Now, using this idea of the substitution, they notice one thing. If the function is even means f of minus x equal f of x. Then the integral from minus a to a is not from any value to any value, from minus that value to the same value, minus a to a of f of x. It will be 2 times from 0 to a of that function. If you even means what? Even means it's symmetric about the y-axis. So if you have a function here, you have the same function here. So this is minus a to a. So from minus a to a, since this is the same as this, so it means minus a to a will be 2 from 0 to a, or from minus a to a. In other words, minus a to 0 is the same as 0 to a. This is for the even function. The odd function is f of minus x equals minus f of x, which is this one symmetric with respect to y-axis. If you remember, y-axis. This one is symmetric with respect to the origin. So if you notice the graph, that means the function will do what? Will do what? If I have this is up to a, and this is minus a. So if you have function here, and the other one, it will be like this. If you notice, this is the same as this. If you think about it as an area, so it will be this minus this one. So they will cancel each other. So the integral will be 0. Or in other words, from minus a to 0 is minus the area from 0 to 1. Or minus the integral. I mean the integral, not the area. I mean the integral from minus a. This integral is similar to this one. But this is negative, this is positive. The result. So the integral of minus a to 0 will be minus the integral from 0 to 1. Okay. Now when you see something very complicated, what to do? First, you notice I have it from minus a to a. You need to think about the even and odd. Okay, so what will happen? Notice f of x is sine cubed x cosine x plus sine x cosine x. What will be f of minus x? Sine minus x is minus, so I have minus sine cubed but power is odd. Cosine at minus x is cosine x. We know cosine. This is minus sine x, cosine x. So I can take minus common factor, and the remaining is f of x. This is what? This is f of x. So this is minus f of x. So f is odd, an odd function. That means this integral will be 0. Right away, this integral will be 0. Okay. Now check this one. Yeah. Same thing. I have minus a to a. So that give me a hint. I need to work it out. Yeah, as even and odd. Especially odd. Even this one, you can't do the integral and do substitution. It will be, you'll get the answer. But sometimes when make it 0 to a number, it will be easier for the calculation. First, I notice the function. This function is even function. Very clear. So I use the idea that will be 2 integral from 0 to 2 x to the power 6 plus 1 dx. I do the integration. That will be x to the power 7 over 7 plus x from 0 to 2. Since I have from this 0, that will make the calculation easier. Instead of doing it for minus 2, do the calculation. Khalas, I have 0, which when I substitute, I'm getting 0. So that will be 2 to the power 7. 2 to the power 7 over 7. I will not write the number. Plus 2. That give me what? 2 to the power 8 over 7 plus 4. So that will be my answer. You can find 2 to the power 8, which is what? Yeah, 8. Okay. This one, first I check this function. This function is odd function. So the answer is 0. Actually, I can't check the function. F of minus x will be tan of minus x over 1 minus x squared minus x to the power 4. That will be minus tan x over 1 plus x squared plus x to the power 4, which is minus f of x. So it's odd function, so the answer is 0. Yeah, let me do this problem, then I will stop with the summary. Okay, this problem, sometimes you need to be careful. Sometimes you need to think about this in different way, and I can split. I have minus a to a, so I need to think about this even odd, but not for all the function. For part of it, I can split the problem into 2 parts. But I notice this one is odd. This minus x cosine minus x cosine. So this is odd. So the answer here is 0. And this one, I know how to find it using the area, like what we did in before. So it's like the area of half circle. So it will be half by r squared, which is 3 squared. So I have 9 pi over 2. So I split it. This is odd, so 0. This one area. So this is my answer. This is just a summary of what we did in 5.5 substitution rule. You need to do it. Yeah, let u equal g of x, change the integral into something you can't do. Definite, also I change the limits. Tan, we did the tan, length secant. This is for the even. If the function is even, I have the integral of minus a to a is double the integral from 0 to a. If it is odd, the integral of minus a to 0. And they have this relation, as I did in the graph, minus a to 0. This will be 0 to a, minus a to 0 will be minus integral of 0 to a. I think I will stop the recording here, and then I will continue. I think we cover the most ideas in this section, 5.5. The remaining is just doing problems. And this is what I will do, inshallah, in the next recordings. Let me just stop the recording. Yeah, thank you.